I would like to thank you for the opportunity to publish within your journal, the International Journal of Electrical and Computer Engineering. This paper is the result of a collaboration with Professor Mohammed Kbir and Professor Yusufi Yasyn in Abd al-Malik Al-Saudi University. It is part of a series of research conducted by our team within the context of the development of customer profiling via their account activity by answering specific questions to build an effective e-commerce platform. I will be presenting to you today for a paper called Product Reviews Analysis to Extract Sentimental Insights with Class Confidence Rate using SOM Neural Network. Customer data analysis helps companies to understand customer intentions and behaviors better. This study introduces an analysis of product reviews to help managers adopt a more efficient strategy to extract valuable knowledge and help detect segments of customers that need a special attention. It can also detect products that need improvement or with the most impact. The used dataset is a set of Amazon reviews divided into multiple categories. Each review has a target column called Overall that takes a value between 1 and 5, which represent the customer satisfaction. Based on this column, multiple labeling methods have been used and compared to get a binary target variable, either positive or negative. It is then affected to a class named review. This dataset contains more than 1 million reviews and can give companies great insights into products, quality, and customers' retention. This work is materialized by using customer segmentation and competitive learning with self-organizing map model and adopted a new approach to explore the generated network and map. It is based on clustering and map nodes labeling using a majority voting process. The results show that the proposed dual approach combining the prior knowledge of supervised learning and the competitive learning abilities enhances the SOM model's capabilities. The impact of using the SOM model will be assessed to help the financial organization make decisions about the suitable strategy to discern customer sentiments and refine the overall product's quality based on sentimental insights extracted via review analysis. Some of the key contributions of this research are extensive dataset use. The dataset includes Amazon reviews focusing on specific categories like magazines and subscriptions, software, and beauty. This comprehensive dataset provides detailed analysis of customer satisfactions and sentiments. Another key contribution is combining the prior knowledge and the clustering capabilities. The research employs a self-organizing map model to segment and predict customer profiles based on their sentiments toward products. It aids in identifying customer clusters and their associated sentiment. The SOM model is first trained with unsupervised manner for initial clustering, followed by supervised labeling and classification using a majority voting process. This dual approach enhances the model's predictive capabilities. The next contribution is improved customer and product insights. The map generated by the SOM model is explored to detect nodes with some particular profiles. This contributes on a better understanding customers' intentions and behaviors. It allows for a personalized product recommendation and targeted marketing strategies, and it also reduces the need for generic marketing companies. This can also offer valuable insights for managers to identify which products need improvement and which have the most significant impact, thereby aiding in product quality enhancement. Next, we have the objective interpretation of SOM maps. It is used to address the subjectivity in interpreting SOM maps. The study suggests using quantitative measures and validation techniques, ensuring accurate identification of relevant clusters. And then we have a thorough model evaluation and fine-tuning. This research involves extensive pre-processing, data scaling, feature selection, and parameter initialization to ensure a good and appropriate implementation of the SOM model. In fact, detailed fine-tuning is needed, which is accomplished by systematic experimentation and cross-validation to optimize parameters such as learning rates and neighborhood functions. This image outlines the process used to classify sentiments in Amazon product reviews through machine learning. It starts with data collection, explicitly gathering an Amazon review dataset. This data then goes through a pre-processing stage, which includes expanding contractions, converting text to lowercase, removing digits and punctuation, eliminating stop words, and lemmatizing the text to its base form. After pre-processing, the data is labeled with Vader tool. It is a pre-trained machine learning tool known for sentiment analysis. Next, TF-IDF, which is term frequency inverse document frequency, was used to transform text data into numerical features for feature extraction. These features are selected using light gradient boosting machine to pinpoint the most relevant ones for classification. Finally, the data is classified using machine learning models such as self-organizing map and compared to the cart decision tree, which categorizes the reviews as positive or negative, thereby identifying customer sentiments towards the products. This research provides a structured method for analyzing customer reviews using the SOM model, enabling better customer segmentation, personalized recommendations, and improvements in product quality. As for the dataset used to train the model, it contains product reviews and metadata from Amazon. It includes more than 400,000 software reviews, more than 80,000 magazine subscriptions, and more than 300,000 beauty reviews, spanning from 1996 to 2018. This dataset has 12 features with different data types described in details in the paper. This research paper works on natural language processing task, which leads to a focus only on text data. The final dataset mixes three sub-datasets belonging to three categories in order to work on the classification of reviews by rating. Before performing exploratory data analysis and converting the dataset to a format that is adequate for models, the following transformation pipeline was adopted: cleaning and feature engineering, cleaning stop words, removing nulls, removing punctuation, label encoding, and lemmatization. This study used the term frequency inverse document frequency TF-IDF algorithm. It is a widely adopted technique for transforming textual content into a structured representation while ensuring the significance of words across the entire document. The paper aims to encapsulate the importance of words within the text and contribute to the overall efficiency of the feature extraction process. The initial corpus consisted of 25,374 features with a target class consisting of positive or negative reviews. Light GBM was used to select the best number of features. It selects an increasing number of the most relevant features to fit the reviews corresponding vectors to the models CART, SVM, and MLP. The image here shows that the results stagnate at a corpus of 100 features. The SOM Neural Network model is implemented using the Minisom library of scikit-learn. The library allows users to explore how often neurons have won the competition. When passing through the dataset samples, fine-tuning is made to give all neurons the chance to participate in contests. The initialization method sets empirical parameters such as network dimensions, as well as number of training cycles. The clusters will be mapped to the problem class using the training samples labels. And then the result is a mesh grid that illustrates the neighborhood relationships between neurons. The algorithm employs a winner-takes-all approach, where the neuron-related weight vector, the closest to the input pattern, is updated along with its neighbors. After training, the network can be used for labeling and classification tasks. In the image, we can see the learning rate, which was initially initialized as a value of 0.9, and then we had a decay function that was used to reduce the learning rate over iterations, as we can see here. Here we can see the SOM map output for different dimensions. The decision to go with the 15-dimension SOM instead of other alternatives such as 5, 10, or 20 can be influenced by various factors. The dataset size and level of complexity are not adequately captured by smaller maps such as 5 or 10 dimensions, yet it doesn't require the additional granularity and interpretation complexity that a 20-dimensional map would provide. The 15-dimension map is also considered to be a more manageable and visually accessible map compared to larger maps. The goal is to spot patterns that could be challenging to discern if there are too many nodes. In the 15-dimensional map, represented in C, in the image C, it is also noticed that all clusters have chosen a class successfully, and in no case were the votes equal or null. It also shows a balance in the attribution of classes with high intensity concentration for both cases, demonstrating the model's ability to classify both intents. Some neurons stand out in this representation, such as the neuron 10, 12, 0, 11, 8, 5, and the intensity of the white color here is higher in these neurons, which means that the data holders should focus on improving the remarks invoked by the highly highlighted circles, keeping the same quality and retaining the customers highlighted in square representation. Here we can see the SOM map grid for output neuron reflecting results in figure C in the previous slide. To choose a class for each cluster, votes were compared for both classes. If the two sums are equal, meaning no class was designated, the representation on the map would be 2. On the other hand, if the first class votes are higher than the second, it would be represented with 0. And if the second class won, it would be represented with one, the number 1. For the nodes that have never won the competition, they are also defined by -1. So one of the biggest challenges when using the SOM model is ensuring that all neuron and nodes of the map participate to the completion and reach a map without neurons labeled with -1 or 2, which means no equals and no null nodes. To add another step of verification for the obtained results using self-organizing maps, a decision tree model has also been used to cluster the data in a tree format, thus enabling the possibility of verifying classification results in both models. The grid search method was used for hyperparameter tuning to get the best results possible based on the data used in this paper. Comparing SOM to CART models rather than other model can be insightful due to their complementary nature. SOM is a non-supervised learning model that visualizes and groups data by finding patterns without predefined labels. In contrast, CART is a supervised learning model that provides transparent and interpretable decision trees that categorize the data based on known outcomes. Since the dataset used in this research is already labeled, we compare the results of the SOM model that defined patterns without labels against CART, a model with labeled training data to use as a basis. This comparison serves as a validation of the unsupervised clusters formed by SOM through CART's structured decision-making. The results presented from the training of a SOM model and classification models on Amazon reviews demonstrate a sophisticated approach to sentiment analysis. However, the SOM model gives a more selective view, which makes it possible not to be satisfied with binary information as output and subsequently to treat all the data in the same way. Indeed, class confidence is an additional measure that provides further information, allowing the examples to be processed according to their importance and possibly providing additional processing for examples with low confidence. Here we have some highlighted reviews in the SOM map, both positive and negatives. For example, a positive review, timeless. I remember reading at my grandpa's house. I'm excited to be an adult now and have my own subscription. I love the jokes and the stories. I hope it's around for my kids' kids. Another example of negative review, I cannot be honest about my problems as Amazon will not post it. Purchase disc only. The product was impossible to set up and ridiculously cumbersome to use. I returned it. And here we have a table with the impression of the review, with the product that the review belongs to, the reference of the product, and the total reviews with the product impression, the overall product impression. So the goal here is to see if the product has really an overall positive product impression. So most reviews classified as positive match the overall product impression. Nevertheless, some of the negative reviews in the table have a general impression that can be considered high and can categorize the products as an average rated product. The reason is that a customer experience may vary widely due to the individual expectations, usage context, or even personal preferences. Products can generally meet or exceed the expectations of most customers. However, it might still not align with everyone's specific needs or expectations, which would lead to some negative feedback. To conclude, the high accuracy and precision of the model, as confirmed by the verification step, indicate its suitability for extracting actionable insights from customer feedback. Thus, businesses can better understand and respond to customer needs. This approach stands out from recent methods due to its thorough pre-processing, which includes steps like expanding contractions, lemmatizing to ensure clean data. We used Vader for reliable initial labeling. We used TF-IDF for effective feature extraction, like GBM for efficient feature selection to boost the model's accuracy. And then combining self-organizing map and card decision tree was used as an approach to leverage unsupervised and supervised learning for robust sentiment classification. Additionally, this method is tailored to specific product categories, providing more targeted and relevant insights.